Alright, so in this video, this is chapter 1, lesson 4. This is where we're going to start in 8th grade math. This section is all about the powers of monomials. Essentially, we're going to use what we know about exponents and properties and stuff. And so our objective is, as the student, I can use laws of exponents to find powers of monomials because I will apply what I know about the product property of powers. What we are going to do first is we're going to quickly remind ourselves what we learned in the past about multiplying and dividing exponents. This is something that our 7th grade group did at the end of the school year last year, so we're just going to take a moment to jog that memory. It's one of those things that looks hard at first, but once you realize it's very quickly to realize it clicks, and all of a sudden all the questions are all repetitive. So that's what we're going to do first. Alright, so as a brief crash course, so we talked about before about the product property of powers. For example, this take the example in the top left corner. I'm being generic by using x, but it can be any letter, it can be any variable. We have x to the third power times x to the fourth power. And if you think about that literally, x to the third power, that means x times x times x. So we have three of them. X to the fourth power, x times x times x times x. And it says those are times each other, so times. So the visual way of doing this is writing it out like this, and then just counting how many x's do you have. And you'll notice that you have 7 x's, so that means our answer is x to the 7th power. Or the fast way would have just been showing it work like this, x and the 3 plus 4, because I'm just adding these exponents, the 3 and the 4 right here, then I made it cross that 3 out. And so that's where that 7 is going to come from. So the answer is x to the 7th power. But so this was the visual way right here. That we did, and then the faster way to show your work is just adding them together. So this is multiplying two variables and you add their exponents. So hopefully that was a reminder how to multiply. I'm sure it was. Now take a look at the example on the right. We're not really going to need this one for today's lesson, but we are going to at least mention it as a brief reminder. If we have x to the 5th power divided by x to the 2nd power, what that literally means is we have 5 x's up top. I like to review this visually, so it helps us remember how that works. And we have 2 x's on the bottom. Now, what we now have to realize is, remember we talked about how if you multiply and divide by the same thing, they cancel each other out. So up top we have times x, and on the bottom, look at that fraction bar. That means we have a divided by x. So since we have nothing but multiplying and dividing this question, we're welcome to kind of go out of order. So what that means is that times x up top and that divided by x on the bottom, they cancel. And in fact, that happens to these as well. But now we have no more x's on bottom, so no more x's cancel. So what you're left with is you're left with these three right here. So x times x times x. Well, x times x times x, that's going to be x cubed. So the fast way we could have showed our work is we could have said x to the 5 minus 2 power. 5 minus 2 is x cubed. So that's the thing we learned when dividing. So long story short, when you multiply variables with exponents, you add them, and then when you divide them, you subtract them. It's just the opposite. Well, as I said, though, we're not really going to use that skill in the top right too much. That's mostly going to be just a review of an old skill. Now, let's focus on the examples on the left. I'm going to do one more example of that, then we're going to jump right in it. Now, even if we had a coefficient, I want to remind you, even if we had, let's say, 3w to the 4th power times negative 4w to the 3rd power. Even if we have coefficients, you can do this. You can go ahead and just multiply those coefficients. And if they're different, you're literally just going to multiply them together. So let's see, 3 times negative 4, that's negative 12. Then it's w to the 4th, w to the 3rd, add those together, it's w to the 7th. So that's going to be our answer to that question. So that was your crash course on product property. Now we're going to jump into and actually do what we're talking about today. Some power of a power is essentially what we're doing. Alright, so I'm going to teach this kind of by just show you some examples. Look at the top left of the screen. We have 4 to the 3rd power, all of that to the 2nd power. Now, if you remember, ignore the 4 to the 3rd power for a moment. Take a look at just to the 2nd power out here. That tells us whatever's in the inside of the parentheses, we have to multiply it by itself, so that we have 2 of them. So that means we literally write this out as 4 to the 3rd power times 4 to the 3rd power. I guess it would help if I wrote those exponents. Now, we have 2 of them because it says squared. That means times itself. So we have 4 to the 3rd power times 4 to the 3rd power. Now, once you have it written like this, it's going to use what we just talked about, that product property. If you want to do this the long way, you literally would have 4 to the 3rd powers, 3 of them, Then 4 to the third power is, again, is 3 of them. Sorry, those 4s are so ugly, using the iPad. Now, as a grand total, we have 6 4s. So that tells us 4 to the 6th power. Same thing here, that equals 4 to the 6th power. So the rule is, when you have a power of a power, if you see an exponent on the outside of, and there's an exponent on the inside of the parentheses that it's referring to, when you actually go to combine those, you're going to multiply them together. And if you look over here at our rule, we said if you have a to the m power, all that is to the n power, n, that means if you multiply those two exponents together, you're going to have your actual new exponent. So in this case, it was 6, because 3 times 2 is 6. So that's the shortcut rather than doing it this long way. You don't want to always write it out the long way like this, because it's going to take a while sometimes to get through questions. Let's say we had 2 to the 5th power, quantity squared. I did squared again out of habit, but it's welcome to be cubed out here to the 3rd power. So let's just say it was cubed. That way you don't think it always has to be a 2. Anyways, we're going to use our rule. We're going to multiply those together. So 5 times 3 is 15, so that means 2 to the 15th power. That is what this equals using the exponent rule. Now, if it told you to actually evaluate it and see what it equals, you're welcome to take a calculator out. You don't expect to do this by hand and see what that equals. And if you did do that, you would get 32,768. Now, again, if whether it says evaluate or not, that's what matters. So if it just wanted to know what it equaled, this is kind of the simplified way to write it. But if it wanted you to actually evaluate it, see what it equals, if it's using the word evaluate, then you would actually see what it equals with the calculator. So take a look at this example I just wrote on the right. So 7w to the 7th power, the entire quantity to the 3rd power. Now, if you have a coefficient, what you're going to do is you're literally going to apply it to that coefficient. Now, you could write this as 7 cubed as a coefficient, but in this case, we're going to go ahead and just simplify and just find out what that equals. Since it's just a coefficient, go ahead and find out what 7 to the 3rd power is. And so 7 to the 3rd power is 343. And then with the w's, with the w to the 7th power, we just do 7 times 3, so that's 21. So that's w to the 21st power. So that is the correct answer to that example. Alright, we're gonna do a few more examples, but I would like if you press pause, try them first on your own, and then hit play and see how you did. So I'm gonna give you a few more examples so we can knock this out, and then we're going to we'll call it done. But I'm gonna go to a new page for it to be fresh. Alright, so give these questions a try real fast. Press pause and see how you did. Alright, for our first one, 5 to the 4th power, remember we do it to the coefficients, the number. So 5 to the 4th power is 625. Now for the j, for the 6, since it already has an exponent, remember if you have a power of a power, you're going to multiply those together. So 6 times 4 is 24. So 625 j to the 24th power. Now make sure you try the second one. If you haven't done so already, press pause. Alright, so our example on the right, 6 to the 3rd power, 6 times 6 times 6. Feel free to use your calculators for this, that's fine. That's 216. And now for those exponents, remember power of a power, so we have to remember to multiply those together. So if we do that, a to the 2 times 3, that's going to be a to the 6. So 216, a to the 6th power. Now b is going to be to the 18th power. 6 times 3 is 18. So that's our final simplified answer of our original expression. We simplified using another exponent property. This is the power of a power. Technically it's called, I think, the power of a monomial. They may call them different things, but essentially the trick here was, you notice we were taking the power, an exponent, the power of a power. So for that reason, that's kind of where we give it that nickname. And also, you'll see it referred to a lot as the power of a product, because essentially what we have in here, this term, 6 times a squared times b to the 6, that's a product. Product meaning multiply. So it's the power of a product. So we're essentially taking that entire term, that entire product of all those items, and we're raising them to another exponent power. Now, before we go further, I want to make sure I point out, let's say this example we have in the bottom left. I wanted to do this real fast because I realized I want to make sure we understand the difference too. Notice, if everything is on the inside is to the 2nd power, that means 2 to the 2nd power, 2 times 2 is 4. But now notice, x doesn't have an exponent. If x doesn't have an exponent, it's technically a 1 if it doesn't have one. So this might help you understand the why, but let's just say it didn't have one visually. Because it's squared on the outside, we have this squared coming in out here, that means we're literally, anything that doesn't have an exponent, we're going to make its exponent that 2. That's kind of what you're doing, but really it's because you're doing 2 times 1 for the x, since it has an exponent of 1. So the x's power is to the 2nd power. Now the y is just like we've already been doing. Y already has a power, so we have to multiply those, so y is to the 6th power. So that's going to be our final answer, 4x squared times y to the 6th power. But I just want to make sure I did an example of explaining to you, if something doesn't have an exponent inside, it now, meaning like a variable, it now gets that exponent, essentially. Now, we'll make these our last two examples just to show you, even if you have scary decimals or fractions, you're just going to have to engage what you learned with your decimal and fraction skills from the past. So what we're going to do is for this first, for the example on the left, we're going to do that one first. Now, just like before, it's a coefficient. If you think you already know how to do these two questions, press pause, feel free, give them a shot. Mostly, I just wanted you to be able to see it does still work, even if you have scary coefficients. Alright, so let's see. 0.6 squared, because it's squared on the outside. That means 0.6 times 0.6. Well, that's going to be 0.36, or 36, and 6 times 6 is 36. So 0.36. Now for the m, power over power, we're going to multiply those together. So 4 times 2. So we're left with 0.36 times m to the 8th power. And that's going to be our final answer to that example. So you're just using your decimal skills. And feel free, at this point, you're allowed to use calculators to double check yourself, make sure you know what 0.6 times 0.6 equals. You could just 0.36. Alright, now let's turn our attention to the example on the right. The example on the right. So let's start with the coefficient. We're raising everything to the 3rd power, it would seem. So 1/3 to the 3rd power, that means, I'm going to write that tiny real fast, that means 1/3 times 1/3 times 1/3. So this might help you visualize it. We multiply fractions, we go straight across, so we're left with 1 on top, and 3 times 3 is 9, 9 times 3 is 27. So 1/3 cubed is 1 over 27. So that coefficient, that's what that gives us. So we have 1 over 27. Now for x, we're going to do 4 times 3 to its exponents, and then for the y, we're going to do 2 times 3. Find out what those are, and that's your final answer. So 1 over 27, x to the 12th power, and y to the 6th power. And that's going to be our final answer for that expression. So it looks scary because of the fraction, but if you just remember your fraction skills, you're good to go. It works exactly the same as all the other questions. So we're going to do a quick recap, and then we're all done, just to make sure we're on the same page. Alright, so essentially we're talking about powers of monomials, or product of, or power of a power, or power of a product, things like that. Because remember, these guys are called monomials. Things like, good example would be what you see on the inside of the parentheses over here. Those would be a monomial, something where there's no adding, subtracting, there's just multiplying or dividing. That's a monomial. Okay, so our objective was I can use the law of exponents to find powers of monomials, or a power of a power, because I will apply what I know about the product properties of powers, meaning we briefly reviewed our crash course on how to multiply with exponents, and we know that we add them essentially as when you had like x cubed times x to the 4th. But then we took that one step further and talked about what if you had an exponent of an exponent, and so we talked about what that means. So if it's a 2 out here, that means that since it was a 2 out here, that means we're going to have 2 of them. We're going to have 4 to the 3rd power, and then times 4 to the 3rd power. There's 2 of them because it's squared. And then at that point, we're just using what we already know about the product property, where we talked about just adding those together for 4 to the 6th power. So that was reviewing an old skill. Then we did another one down here. Now, if you ever, some people like to see the symbol version, that's what you have over here. If that's the rule that helps you remember it, so be it. And then we went further and just remembered, we reviewed how to do it if you have a coefficient. And so if you have a coefficient, you literally just do it, that operation to the coefficient. So we had a 4 out here, so 5 to the 4th power, with your calculators, feel free, is 625. So if you have a coefficient, we're going to go ahead and apply it to it so that we can go ahead and just clean it up rather than have just more exponents in there. And so we've done it, we did examples with decimals and fractions. So at this point, you've seen quite a few of these to where now you should be ready to practice this and apply this on your own, and then maybe we'll take it to the next level. Good luck, guys. I hope this will provide you some insight.